in the end of this journey, we know that whatever it is Android native, whatever it is Flutter, whatever it is Kotlin Multiplatform, or whatever it is React Native, the important is to have an umbrella to include all of them. Hello everybody. So, all together under my umbrella. But what does it mean? We mean about the weather, the rain? Yeah. In this foggy day, I think that you need a torch, not an umbrella. But it's not that kind of umbrella. We are talking about umbrella module. But if you are Android native developers, like me, I think that you will develop your umbrella module in Android native, right? How many Android native developers in here? Wow, we are still a lot. We are resisting. So, yeah, we will develop in Android native. And then we usually include Android native modules under Android native umbrella, for sure. But I think that we can try to be more inclusive, right? So, inclusivity is a big word, I know. But it's impacting even us as developers when we work with developers with other skills. For example, for Flutter, for Kotlin Multiplatform. So, why don't include all of them under our Android native umbrella? But before that, I think that we need to do one step back to modularization, which is an important keyword, and I'm pretty sure that you all know the modularization. You are already using modularization in your project. Modularization is a good practice to divide your project in some packages, and you can also parallelize the build, which is useful for build time, but also for organization you can create some feature, modules as features. So let's imagine that your app or module, umbrella module, is including some features, and then optionally they can have a core in common, right? In our project, our goal for today is to create a module that is including some features, Android native features, but also Flutter module and also Kotlin Multiplatform modules. Okay. But before proceeding, just some brief information about me. I'm leading the team in Android developer team in Intesa Sanpaolo, which is the first bank in Italy. And we are a new team, and we are developing new features to our projects. We have many apps and 2 very bigs, so we are going to develop new things. Flutter is an open source cross-platform framework, and you all already know them. How many Flutter developers in here? Good. So, Flutter is deploying, as you know, apps on other platforms. We are focusing on Android today. So, we imagine that our module is including a Flutter module, but in which way? The Flutter module, we create a package as Flutter framework, and it will have under lib folder the main .art file or whatever you want, which is the screen and the app in Flutter that you will develop. But it has also an important folder for us, which is .android, and in there will be all the files that we need to include in Android part. So the Flutter skin will be main.art. Now, Because I'm going to switch between different languages, different frameworks, I introduced an icon just to specify, to identify the code block from which framework is related to. So I just used the generative AI to create a black hat, and the black hat was generated like an umbrella. I don't know why, but it's good. So we are going to use these icons for specific frameworks. So we have the Flutter screen. It's a simple Flutter screen. We have the main method to run the app, and we have our app, which is in this case stateless widget, but could be also stateful, whatever you want. What I need now is just to identify. So we have a title. I am from Flutter Module A because we are integrating, including Flutter Module A into our app. So on native side, Android native side, we have to use the Gradle part to include. So how to do that? Download the Flutter framework first through Maven. Then you can use this code in order to include the Flutter Module A. The Flutter Module A can also be published as an artifact. You can use as dependency. It is depending on your organization in your project. But what is really important here is to focus on .android folder generated into Flutter package, which is include _flutter.groovy. It's very important because that Groovy file will configure the Android part from the Flutter package into your native module or app. So on the Android native side, we are in our screen. So we are in an activity in the onCreate, and we are using Compose. Okay. So we have a column. We are just including a button. Flutter button is not coming from Flutter framework. It's just a composable, which is just having a blue color just to identify for Flutter. So our screen will be like that. Okay. So we can start the communication between the Flutter module and the Android native side. How to connect, how to inflate the screen part from Flutter to Android side. There is one approach, which is the root. So we have, firstly, the object Flutter Engine, which is very important in this kind of approach. And Flutter Engine is coming from Flutter framework. Flutter Engine is managing the communication, is managing the instance of Flutter module, and we need an anchor for Flutter module, which is the root in this case. So Flutter Engine will retrieve the root. So we are going back to our Flutter part in our app, and we can set the initial root. In this case is a /market. So on Flutter button, we can just manage the onClick, and we can start an activity. And in this case, we have another object from Flutter framework, which is Flutter activity. Flutter activity as a builder. And with the builder, you can instantiate a new Flutter engine and then set your initial root, which is market. In this way, on the click, you can open the Flutter module A, and it's done. But what if you want to include more Flutter modules in your umbrella module or app in Android native? The problem is that the first time it loads a module in Flutter, it doesn't know about the other modules. So how to specify what what is the anchor for Flutter. We can create a Flutter big module, a wrapper module, and we embed all the Flutter modules in there. In this case, Flutter A and B. So we have another approach, which is just like the root, but is another anchor. It's called entry point. So Flutter Engine will retrieve the entry point. So we are going to Flutter part, and we have to import our packages because we are in the wrapper module, the Flutter big module, and we are going to import module A and module B. So we are going to declare a pragma class from Flutter, and we are going to impact on the virtual machine, Dart virtual machine, with the entry point, declaring our module A. The same thing for module B. You need to focus on these names because module A and module B will be the strings, the anchors to connect on these modules. So we can create an ARM class, select class, whatever you want to keep the information. So we are going to keep module A and module B as strings because they are our entry point, our anchors. So we go on Flutter Engine part to instantiate into Android native part into our application. In this case, it's comfortable for me, but you can declare that wherever you want, and you can create a Flutter Engine group. Flutter Engine group is coming from Flutter framework and is instantiating multiple Flutter engines, because for each Flutter engine there is only one anchor. So we are going to declare another class from Flutter framework, which is Dart entry point, and is going to get the entry point that we are going to pass. In this way, we are going to create and run the engine for that entry point. When we are in our Flutter module activity, which is an activity that is extending the Flutter activity, which is coming from Flutter framework and we saw before, we are going to override an important method, which is provide Flutter engine, because we are going to pass the Flutter engine that we want to inflate and to render. So we are going to pass the information for Flutter engine. So instantiate it and pass it. At this point, we can just call our Flutter module activity with the entry point that we want to render, and it's done. Okay, so we click on Flutter module A, and we have a Flutter module A. We click on Flutter module B, and we have a Flutter module B. Easy. In this case, we have done the first step, which is the communication with the entry point. So we have two modules that we are running. But I don't know if you saw that we are wasting some time for loading the module because it's costly. So there is another phase that we can use, which is the pre-warming phase. We are preloading the Flutter engine before render it. In this way, it will be faster. So in our Flutter module info, we can just add some key. So for example, we can add SID, mod_A, and so on. Okay, it's totally arbitrary, it's a string. We are going to use another object from Flutter framework, which is the Flutter Engine Cache. So we get the instance from Flutter Engine Cache, and we can just use it as a map, because it's key value. So the key we registered before, as a value, there is the Flutter engine that we instantiate. To retrieve from the cache, we can do the same from Flutter engine cache, and we can get through that key, the engine ID. There is also another way, because you can use always the Flutter activity, which has a builder, and you can pass directly the key, and you can get the Flutter engine. It will render automatically, which is even easier, but if you want to customize, it's better the previous way. So we are going to pre-warm the Flutter engine, and we are going to run it in a second time. It will be faster, basically. No difference from native performance. There is also another thing from Flutter framework, which is the fragment, Flutter fragment. The Flutter fragment is basically a fragment that is renderize your entry point or root, and you can use it in our layout, in your activity. So we are going to run two modules as fragments, and as you know, we have in the half screen, top and bottom, we have two modules on the same activity, because they are fragments, basically. How to pass the parameters? It's very important. Parameters can be passed in the entry point, in the begin. So when we declare that entry point, we can also pass a list of arguments. They are all strings, so you can get the first one, second one, but you already know which is the type, because they are all strings, basically. But if you want another approach, maybe during on demand you want to send some parameters on the fly, you need to use the channels. There are several channels from Flutter framework. Today we will focus solely on method channel, and we have to focus on a basic scenario, a counter that we increment with the button, basically. I want to pass the counter through native and Flutter. How to do that? We have the counter instantiated, and we have the method channel with a proper string. In this case it's Flutter channel. We have two methods. Increment counter from Flutter is incrementing on Flutter. Increment counter from Android is getting from Android an increment on Flutter. So in Android side we can do the first thing, increment Flutter counter. So from Android we increment on Flutter. So we invoke the method, which is called as we want, increment counter, for example, it's totally arbitrary, it's string. And on Flutter side, we are listening to that method, increment counter, and then when it's triggered, we can call our function to increment the counter. And you have something like that, basically. Easy. From Flutter to Android, the inverse, the opposite way, we can do the same. And the syntax is very similar. They are the same classes. So you can invoke the method, always increment counter. And on Android side, we are listening for that counter, for that method, and we can increment the counter. And it's in this way. So we are pressing the button on Flutter side, and we are incrementing on Android side, Android native side. The problem is that Flutter framework is not coming for free. It's coming with sides that impact your APK, your app bundle. So if you're running in issues with your sides, this is a problem. So maybe you can use a feature from Google Play, for example, which is dynamic features. We can think about two methods from dynamic features, but in this way maybe it's better on demand. and we can set up in this way. We have the native app or module. We are creating an Android native module, maybe the umbrella module, which is the dynamic feature, and it's including the Flutter side, the Flutter framework with all the Flutter modules. In this way you can get the package on demand. How many of you are using dynamic features? Wow. Oh, very good. So, we can go on Kotlin Multiplatform. On Flutter we talked about 20 minutes. Now we'll see on Kotlin Multiplatform how much. Because Kotlin Multiplatform is coming from JetBrains, as you know, the author of Kotlin, and Kotlin Multiplatform is also embedding Compose, Jetpack Compose, that we are using also in our Android native apps. So we are going to include in this path, we are going to include also the Kotlin Multiplatform module. And we have a Kotlin Multiplatform screen that we have in common main folder, which is in common between all the platforms, and it's in Compose. But we have also the Kotlin Multiplatform activity that we created in Android specific side because it's an Android object, and we are going to call that activity. So we have Android activity and Compose on Kotlin Multiplatform side. So let's see how to call it. On Kotlin Multiplatform screen, we can see that. Just welcome to Kotlin Multiplatform in Compose. Activity in Kotlin Multiplatform is just rendering the Compose side, so inside content, as you know. Nothing more. In our Android native side, we are just starting the activity. We don't have to do something else. We don't have to use proper object, specific objects from Kotlin Multiplatform side. We don't have to use engines. So, recapping, we are going to know Jetpack Compose. Jetpack Compose, which is declarative UI. Jetpack Compose, which is a new way to develop the UI side on our Android native side and native app, but also on Kotlin Multiplatform. We know the Flutter fragments, which are fragments that are rendering the Flutter engine entry points, a root. So they're rendering the Flutter side. We know the Flutter entry points, which are the anchors for our Flutter modules. We know the channels for Flutters to communicate and to pass parameters. Okay? And finally, we know the Flutter cache to preload the modules and run them faster than a cold start. So we can do something like that, right? We can have an Android activity, Android native activity, which is having just a button incrementing the counter on Kotlin Multiplatform and Flutter side. In the center part we have a Flutter fragment with one Flutter module, which has the counter, and the Kotlin Multiplatform side is just the composable that we put in the bottom side of Android native activity. So it's only one activity and it's communicating with 3 frameworks. But there is a good friend of mine that could be offended if I don't talk about React Native. Maybe because I'm an Android native developer and I have no web-oriented skills, so I'm not comfort to go to React Native. But React Native is having something like that. We don't focus on that, but it's possible. There is a React Instance Manager, which is just like the Flutter engine. It's communicating with the React Native side. And there is a proper view from React Native that is rendering the React Native module. So it's possible. But I'm throwing the challenge to you. So, in the end of this journey, we know that whatever it is Android native, whatever it is Flutter, whatever it is Kotlin Multiplatform, or whatever it is React Native, the important is to have an umbrella to include all of them. Thanks.